Alright, hey guys, welcome to Math 6 2.1, Chapter 2 is what we're starting here, and we're talking about multiplying fractions today. Alright, so before we start, we need to make sure we're good on something, and so what I want you to do is I want you to pause the video, and I want you to try these two sets of problems here, play it when you're done, and let's just see how you do. Okay, so turn the following mixed numbers into improper fractions. This is really important today. So let's take this mixed number here and turn it into an improper fraction. So remember, how do we do that? Well, we have a new fraction, and that is our denominator multiplied by our whole. Okay, so 5 times the 3. But then we're going to do that first, and then we're going to add the numerator of 4. And we're always going to put that over the denominator, in this case 5, right? So what would that turn into? Order of operations, I need to do the multiplication first. So 5 times 3 is 15, plus 4, that's 19 over 5. 7.5 here, 2 times 7 is 14, plus 1 is 15 over the 2, right? Now going in reverse here, we're going to turn the improper fractions into mixed numbers. We remember that we're trying to put this denominator into the numerator. And can only go in there a certain number of whole times. So how many times is 11, all of it, go into 18? Only once, and so that's the whole number part of our answer. But what's left between 11 and 18? Though the difference of those two is 7, and we keep the 11. All right, and you can check your work. If you multiply 11 times 1 and add 7, you get back to 18, right? So we know we did it right. Same thing over here. 10 goes into 39 how many times? Well, once, but also twice and also 3 times, right? So that gives us 30. So it goes in there 3 whole times, which gave us 30. What's the difference between 30 and 39? 9 out of 10. All right, so we have to be good on that before we can go forward and do the following lesson. All right, so let's multiply some fractions here, okay? Multiplying fractions, super easy, straight across the top, straight across the bottom. Okay, so we have our two fractions set up here. They're both regular fractions. If they were improper fractions, that'd be fine too. So multiply straight across the top. 2 times 1 is what? 2 over 5 times 4 is what? 20. And we're done, right? Wrong. Okay, why are we not done? Well, look at this fraction, 2/20. It can be what? Simplified, okay? So what do I mean by simplified? Just, I'm asking, are there any common factors that go into both 2 and 20? Well, actually there are. What is both a factor of 2 and 20? 2, right? I can divide 2 by 2 and 20 by 2. And when I do that, what's 2 divided by 2? It's 1. What's 20 divided by 2? It's 10. So my answer is 1/10. Now, there's an easier way to do that that helps us not have to simplify at the end. So I'm going to rewrite the problem as 2/5 times 1/4. And now we need to talk about cross-canceling. Okay, what do I mean by cross-canceling? Let's look here. Cross is going to mean the denominator of one fraction to the numerator of the other, or vice versa. So these two and these two. And when I mean cancel, I mean, again, common factors. So is there a common factor between 5 and 1? No, except for 1, but we don't really use 1 because it doesn't help us. But between 2 and 4, what could I divide both 2 and 4 by? Same number. Well, 2, right? I could divide 2 by 2, and I could divide 4 by 2. And because they're across from each other, we're going to do that. So I'm going to rewrite the problem now. 2 divided by 2 gives me a 1 over 5 times 4 divided by 2 is 2, so that turns into a 1 over 2. Now, is there anything else I can cross-cancel? Well, 1 and 2? No. 5 and 1? No. So now that I'm done cross-canceling, I actually know my answer is going to be as simple as possible. So go ahead and multiply across the top. 1 times 1 is 1. Across the bottom, 5 times 2 is 10. And because we cross-canceled, that is our final answer. No simplifying necessary. Alright, so go ahead, pause the video, try this one, and play it when you are done. Okay, so hopefully you were looking at this and realized there's some cross-canceling that can happen. If I look at these two right here, 4 and 24, I can divide both 4 and 24 by 4, right? So that's going to turn that, and I'm just going to, instead of rewriting it this time, I'm just going to cancel, and 4 divided by 4 is 1. So I'm writing a new numerator right there. 24 divided by 4 is 6. It's a bad 6. Now, 7 and 21. Is there something that goes into both of those? Actually, yeah, 7, right? Okay, so what is 7 divided by 7. Well, 7 divided by 7 gives me a 1. What's 21 divided by 7? It gives me a 3. So now when I go ahead and multiply, because there's nothing else I can cross cancel, a 1 over a 1 and a 6 and a 1 and a 3. So that go ahead and gives me, let's see, 1 times 3 is 3, 1 times 6 is 6. Now I'm done, right? Wrong. Why am I not done yet? Because I can still simplify. You might be saying, well, I thought you said because we cross cancel, it means we don't have to simplify at the end. It's true if there's no more cross canceling to do, and our fractions here, our new fractions, are simplified. But look, 1 over 1. That's really as simple as it gets. You could write it as just plain old 1, but when we're multiplying fractions, you really need to leave it as a numerator over a denominator. But what's 3 over 6? Well, 3 over 6 is actually what? It's 1/2, right? So I could have actually even simplified this further and said, well, 3 over 6, it's not really cross-canceling here as much as it is simplifying, just 1 over 2. So really, I'm multiplying 1 times 1, which would actually be 1, and 1 times 2, which is actually 2. So either way you do it, you should get a half, no matter if you cross-cancel and simplify at the end, or if you cross-cancel and then you simplify that, and then you get your answer. Or if you don't do anything, any cross-canceling or any simplifying here, you just multiply 4 times 21 and 7 times 24 and simplify that. You should get the same answer of a half. All right, so next problem. What if I saw this? 3.5 times 4. What do I do? Okay, well, we need to make either proper or improper fractions. Probably the best way of doing this, better to get rid of any whole numbers, okay? So let's turn this into an improper fraction. 2 times 3 is 6, plus 1 is 7 over 2. So 7 over 2 times, and then you might be saying, what about 4? What do I do with that? Well, 4 is actually the fraction 4 over 1, or 4 divided by 1. Why is that? Well, because think of the number 4. If you take 4 and you divide it by 1, which putting something over 1 in a fraction is the same as dividing something by 1, you're still left with 4. The value of 4 did not change even though we did that to it. So that's why we can write 4 as 4 over 1. And now we can just multiply. Can we cross cancel? Absolutely. The 2 can become a 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. So we cross canceled there. Can I simplify here? No. Simplify here? No. So 7 times 2 is what? 14 over 1 times 1 is what? 1. So what is our answer? 14 over 1, we can actually just write that as the number 14. And we're done. Alright, so pause the video and try this one. See how you do after you play the video. Alright, so 5 1/8 times 4 thirds. Got to turn that into a improper fraction. 8 times 5 is 40 plus 1. 41 over 8 times 4 thirds. So I change that? No, leave it as 4 thirds. So before I multiply straight across top, straight across the bottom, is there anything I can cross cancel? There definitely is. 4 and 8. What's the greatest common factor of 4 and 8? It's 4. So divide them both by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now let's multiply. 41 times 1 is 41. 2 times 3, though, is 6. So here's the question. Should I leave it? It's probably okay to leave it like this, but we really should get in the habit of being able to turn them into mixed numbers. Now, when we get to algebra, in Algebra 1, we start talking about things like slope, you want to leave them as improper fractions. But for now, let's go ahead and change it into a mixed number. 6 goes into 41. 7 times? Not quite, because 6 times 7 is 42. So if it doesn't go in there 7 times whole, probably going to go in there 6, right? So 6 times 6 is 36. So that will work. It's going to get in there 6 times whole. In between the 41 and the 36 that we get by multiplying 6 by 6, what's the difference there? It's 5. Okay, so what's our answer? 6 and 5/6. Now, how can I be sure I changed the improper to the mixed correctly? What's 6 times 6? 36. Add 5, 41. So really, I'll say 41/6 or 6 and 5/6 is our answer. You need to be prepared to give both styles of answer. Alright, so I'm actually going to leave you with this problem here, so I want you to just read it through real quick with me. You're creating a horseshoe pit in your backyard. Dimensions are shown right here in the photo. Okay, so you probably ought to, if you're in your notes, sketch something that looks, you don't have to draw it in this perspective. You can just draw it as a rectangle. And I would draw, 20 and a half and 6 feet, of course. And then, write this down. The gravel costs 35 cents per square foot. What is the cost of the gravel that you need? So I want you to work on that. Come to class ready to talk about it, and I will see you then.